Hello everyone, welcome to our channel Franklin's Touch. Today we are going to discuss on the various types of AC motors. Let's get started. All AC motors are broadly classified under two heads as induction or asynchronous motors and synchronous motors. The induction motors are broadly classified into two, known as the squirrel gauge and the wound rotor motors. Under squirrel gauge motors comes the three-phase and the single-phase motors. The single-phase motors are further classified as shaded pole and split-phase types. The capacitor start, capacitor run, capacitor start and run, and resistance start are the various subvariants of the split-phase squirrel gauge induction motors. In this video, we will discuss in detail the various types of squirrel gauge induction motors alone. Three-phase squirrel gauge induction motor. It is called so because of the rotor which is placed inside it looks like a squirrel gauge. It is a type of three-phase induction motor which function is based on the principle of electromagnetism. Now, let's see its working principle. When a three-phase supply is given to the stator winding, a rotating magnetic field is generated. Due to the magnetic field generated, a voltage is induced in the rotor bars and induces a current to flow through it. This induced current creates a magnetic field which gets interacted with the field of the stator. The interaction between the two fields generates torque which allows the motor to start and move the rotor in the direction of rotating magnetic field. The symbol used to represent the three-phase squirrel gauge induction motor is shown in the figure. The various applications of three-phase squirrel gauge induction motor includes crushers, lathe machines, oil extracting mills, lifts, hoists, textiles, cranes, and large exhaust fans. Now, let's see the various advantages and disadvantages of the three-phase squirrel gauge induction motor. High reliability, high torque at low speed, wide range of speed control, small and lightweight, low maintenance cost are its advantages, and the various disadvantages includes low efficiency, poor power factor, poor starting torque, high inrush current. Shaded pole squirrel gauge induction motor. It is simply a self-starting single-phase induction motor whose one of the poles is shaded by the copper ring. The copper ring is also called the shaded ring. This copper ring acts as a secondary winding for the motor. Let's understand the working principle now. The main winding carries the alternating current and generates the magnetic flux in the stator coil. Uniform magnetic flux is cut by the shaded band of the copper. This will induce EMF in the copper band. This EMF conducts current, and this current generates its own magnetic flux in the shaded band. According to the Lenz's law, the flux in the shaded band opposes the main stator flux. This causes a slight magnetic imbalance and generates a rotating magnetic field. The symbol used to represent the shaded pole squirrel gauge induction motor is shown in the figure. The applications of the shaded pole squirrel gauge motor includes refrigerators, table fans, hair dryers, exhaust fans, cooling fans, air conditioners, and projectors. The various advantages of the shaded pole squirrel gauge induction motor are its lightweight, compact size, high reliability, low maintenance, cost effectiveness, self-starting, simple design. The various disadvantages includes lower speed and performance when compared to the other AC motors, poor power factor, low efficiency due to power loss in the shading coil, inability to reverse the direction of the rotation without design modifications, limited starting torque. Split phase squirrel gauge induction motor resistance start type. It's a type of a single phase induction motor in which the stator is provided with a starting or the auxiliary winding and a main or the running winding. Both the windings are displaced 90 degrees in space. As usual, it has a single cage rotor. The working principle of split phase squirrel gauge induction motor is that as its main winding has very low resistance and a high inductive reactance, whereas the auxiliary winding has high resistance and low inductive reactance, the current in the two windings is not equal. As a result, the rotating field is not uniform. Hence, the starting torque is small, of the order of 1.5 to 2 times the stated running torque. At the starting of the motor, both the windings are connected in parallel. As soon as the motor reaches the speed of about 70 to 80% of its synchronous speed, the starting winding is disconnected automatically from the supply mains. If the motors are rated above 100 watts and more, a centrifugal switch is used to disconnect the starting winding, and for smaller rating motors, relay is used for disconnecting of the winding. The symbol used to represent the split phase squirrel gauge induction motor resistance start type is shown in the figure. The various applications of the split phase squirrel gauge induction motor resistance start type are household appliances like fans, table fans, exhaust fans, mixers, grinders, portable power tools like drills, grinders, small lathes, drill presses, saws, cooling towers and centrifugal pumps, conveyors and elevators with small starting torque requirements, small blowers and compressors require an economical single-phase induction motor. The various advantages are self-starting capability, low production cost, simple and rugged construction, low maintenance cost, silent operation, wide range of power ratings, nearly constant speed characteristics for centrifugal loads. The disadvantages include less starting torque, applicable for loads up to 1 kilowatt alone. split phase squirrel gauge induction motor capacitor start type. These motors employ a capacitor in the auxiliary winding circuit to produce a greater phase difference between the current in the main and the auxiliary windings. Let's understand the working principle. The capacitor start motor has a cage rotor and has two windings on the stator known as the main winding and the auxiliary winding, which are placed 90 degrees apart. A capacitor is connected in series with the starting winding. A centrifugal switch is also connected to the circuit. The motor acts as a balanced two-phase motor. As the motor approaches its rated speed, the auxiliary winding and the starting capacitor are disconnected automatically by the centrifugal switch provided on the shaft of the motor. The symbol used to represent the split-phase squirrel gauge induction motor capacitor start type is shown in the figure. The various applications of the split-phase squirrel gauge induction motor capacitor start type are loads of higher inertia where frequent starting is required, refrigerator and air conditioning compressors, pumps and compressors, split-phase squirrel gauge induction motor capacitor run type. Let's see its construction. These motors have a cage rotor and its stator consists of main winding and the auxiliary winding. These motors have only one capacitor which is connected in series with the starting winding. The capacitor is permanently connected in series with the starting winding. The capacitor is permanently connected in circuit at starting and running conditions. The symbol used to represent the split-phase squirrel gauge induction motor capacitor run type is shown in the figure. The applications of split-phase squirrel gauge induction motor capacitor run type are fans and blowers in heaters, air conditioners, drive refrigerator compressors, operate office machineries. The various advantages are higher power factor, higher efficiency, higher pull-out torque, centrifugal switch is not required. The various disadvantages are a single value capacitor has a low starting torque, usually less than full load torque. Electrolytic capacitors cannot be used for continuous running. Paper capacitors of the same rating are larger in size and more costly. Split-phase squirrel gauge induction motor capacitor start and run type. Here, the starting winding is connected to the power supply through a capacitor. The capacitor causes the starting winding current to lead the main winding current by 90 degrees. The capacitor C1 is permanently connected in series with the starting winding and C2 along with the switch S in parallel to the starting winding. The capacitor C1 is permanently connected in the circuit at starting and running conditions, while C2 is opened by means of a switch S once it reaches near to its synchronous speed. The symbol used to represent the split-phase squirrel gauge induction motor capacitor start and run type is shown in the figure. The various applications of the split-phase squirrel gauge induction motor capacitor start and run type are hoists, cranes and elevators, screw compressors, conveyors, fans and blowers, rolling mills, welding machines, X-ray machines, ventilators, etc. The various advantages are low installation and maintenance cost, operates at higher efficiency, low mechanical life, uniform speed under varying load, self-starting, quiet operation, high starting torque, higher efficiency, improved power factor, compact and lightweight, exhibits constant torque characteristics. The various disadvantages are its higher loss, direction reversing is complex, internal construction is complex, capacitors are prone to fail, higher capital cost, capacitor sizing is critical for optimal performance.